Okay, so hi guys. In this video, we're just gonna be simplifying some exponents, right? That are actually multiplying and dividing. Say we are having 2 to the power of x multiplied by 12 to the power of x minus 1 multiplied by 3 to the power of 2x divided by 6 to the power of 3x minus 1, right? So before we even solve this problem, let's first simplify this 12, right? 12 is formed by 6 times 2, right? Or you can say 4 times 3, it's up to you. Or 12 times 1, it's just up to you. So then from here, this 6 here is formed by 3 times 2. So 3 times 2 multiplied by this 2 here, right? So now I'm having 3 times 2 times 2, right? And then this 3 will remain, and then these are same bases. You add the exponents, so it's multiplied by 2 to the power of 2. So this is actually equals to 12. So I'm just going to write this down. So meaning I'm going to have 2 to the power of x multiplied by 3 multiplied by 2 to the power of 2, which is what I got here. And then all multiplied by the power of x minus 1 multiplied by 3 to the power of 2x divided by, right? And then here, we're having 6 to the power of 3x minus 1. So let's break down the 6. So 6 is formed by 3 times 2, right? And then just going to write that down. So we'll have 3 times 2 all to the power of 3x minus 1. Okay, then from here, we're going to multiply this power here of x minus 1 inside the brackets, right? Including here, we're going to multiply the power inside, right? So the power will multiply everything that is inside. So you're going to have 2 to the power of x multiplied by, so it's going to be 3 to the power of x minus 1 multiplied by 2 to the power of 2 into x minus 1 multiplied by 3 to the power of 2x divided by 3 to the power of 3x minus 1 multiplied by 2 to the power of 3x minus 1, right? And then from here, what we will do is just going to multiply these 2 inside, right? So you will have 2 to the power of x multiplied by 3 to the power of x minus 1 multiplied by 2 to the power of 2x, right? Because this 2 multiplied by this x gives you 2x, and then multiplied by 2 to the power of minus 2 multiplied by 3 to the power of 2x divided by 3 to the power of 3x minus 1 multiplied by 2 multiplied by 2 to the power of 3x minus 1. So you can see now that we are done with multiplying out. So now we can expand this. We can expand this, expand this, and expand this, right? So we're going to have 2 to the power of x multiplied by 3 to the power of x, right? Multiplied by 3 to the power of minus 1. The expansion of this. And then multiplied by 2 to the power of 2x multiplied by 2 to the power of minus 2 multiplied by 3 to the power of 2x divided by, we simplify this, going to be 3 to the power of 3x multiplied by 3 to the power of minus 1 multiplied by 2 to the power of 3x multiplied by 2 to the power of minus 1, right? So if you're having problems with expanding these, please let me know in the comment section. Let's continue. So now, what we have is this 3x here, which we can add with this one. What do I mean add? We're adding the exponents, right? So these are the same bases. We add exponents, and yeah, let's do that. And even these 2 here, we're going to add its exponent with this one, right? Because they share the same base. It's going to be 2 to the power of x multiplied by 2 to the power of 2x, right? So I'm done with these. Just gonna mark them out. And then multiplied by 3 to the power of x multiplied by 3 to the power of 2x. I'm done with these. And then I remain with 3 to the power of minus 1 multiplied by 2 to the power of minus 2, right? Divide by 3 to the power of 3x multiplied by 3 to the power of minus 1 multiplied by 2 to the power of 3x multiplied by 2 to the power of minus 1. Fine. So now I collected the bases with the same exponents. So I'm just going to add the exponents, right? I'm going to add this exponent here with this exponent here. I'm going to add this exponent here with this exponent here. So it's going to be 2 to the power of 3x multiplied by 3 to the power of 3x multiplied by 3 to the power of minus 1 multiplied by 2 to the power of minus 2 divided by 3 to the power of 3x multiplied by 2 to the power of 3x multiplied by 3 to the power of minus 1 multiplied by 2 to the power of minus 1, right? And then from here, what I'll do is, if you can see, this 2 to the power of 3x is the same as this 2 to the power of 3x. So they divide out. Why do they divide out? If you have x over x, they divide out. It's just equals to 1, right? Or if you have 2 over 2, they divide out. It's just equals to 1. So the same thing applies here. So this goes away with this one, and including this goes away with this one, and this goes away with this one. So we remain with 2 to the power of minus 2 over 2 to the power of minus 1, right? So you can apply your laws of exponents by saying if they divide, you subtract your exponents, right? But I'm just going to take this to the top to make it simpler. So when I take this to the top, the exponent of minus 1 changes to become positive 1. So it's going to be 2 to the power of minus 2 multiplied by 2 to the power of 1, right? So now you have same bases, you just add exponents. So it's going to be 2 to the power of minus 2 plus 1, right? Of which is 2 to the power of minus 1, right? And if you have an exponent that is negative, according to the definitions, we have to write it in a positive manner, right? So the same applies here. So it's going to be 1 over 2, right? So that is the answer for this question here. It's actually 1 over 2. Please note, guys, when you have these type of problems, I like them because you are able to identify the answer. You need to always check whenever you are done. In this case, we know that the answer is actually equals to 1 over 2, right? But we're not sure. We just know because we simplified everything and we are done. Always check on your answer. Always check. Check on whether your answer is correct. How do you check? You go back to your original equation or your original problem, which is 2 to the power of x multiplied by 12 to the power of x minus 1 multiplied by 3 to the power of 2x all over 6 to the power of 3x minus 1. So this expression here, you have this expression. It's the original expression that you were given as the question to simplify it, right? So you're going to test and see if this 1 over 2 is actually the correct answer. How do you do that? Where there's x, you substitute any value of x that you think of, but constant. You can't just substitute one value here and substitute a different one here, right? Substitute one constant value of x. If, let's say, for example, let's say x is equals to 1, then substitute 1, 2 to the power of 1 multiplied by 12 to the power of 1 minus 1 multiplied by 3 to the power of 2 multiplied by 1 over 6 to the power of 3 into 1 minus 1. So you substitute 1, right? And punch that in your calculator and see the answer it is going to give you, right? So if it gives you 1 over 2, then you know that the answer that you got, is actually the right answer. Or you can literally substitute any value. You can substitute 3. So you can substitute 3. Where you substitute 1, you substitute 3. It's as simple as that. That's why I really don't want you guys to be getting wrong here. So you can substitute 3 if you want. You can substitute any value of x actually, right? And check on whether or not your answer is correct, right? Thank you so much for watching. Now we are going to continue. There's one problem that I'd like us to do, and then from there I give you guys some problems to do. So let's continue and do one interesting problem that I have here with me. It's the root of 4 to the power of 2n minus 4, right? And it's multiplied by 8 to the power of 5 minus 2n all over the root of 16 to the power of 6 minus 2n, right? And then from here, what do? You first need to simplify this 4, simplify this 8, simplify this 16. How do you do that? 4 is formed by 2 times 2, right? Of which 2 times 2, this is the same base, you add exponents. So it's going to be 2 to the power of 2. Done. And then the 8 is formed by 4 times 2, of which 4 we just said it's 2 to the power of 2. So you're just going to say 2 to the power of 2 multiplied by 2. And then same base, you add exponents, so it's 2 to the power of 3. And then for 16, 16 is formed by 8 times 2. We just said 8 is 2 to the power of 3, right? So it's multiplied by 2 to the power of 1. And therefore it's 2 to the power of 4, right? So please substitute that in your expression. So it's going to be the root of, for 4, we said it's 2 to the power of 2. So it's going to be 2 to the power of 2 multiplied by 2n minus 4, right? Don't forget that. Multiplied by 8, we said it's 2 to the power of 3. So it's 2 to the power of 3 multiplied by 5 minus 2n. Divide by 16, we said 2, it's 2 to the power of 4, so it's going to be the root of 2 to the power of 4 into 6 minus 2n, right? And then from there, what you'll do is we're going to multiply this 2 inside here and here. The same applies with this 3, we're going to multiply it, and this 4, we're going to multiply it. So the answer that you'll be getting is 2 to the power of 4n, right? Because it's 2 times 2n. And then minus 8, because it's 2 times minus 4. Multiplied by 2 to the power of 15. Multiplied by 2 to the power of minus 6n, right? So it's going to divide by the root of 2 to the power of what? 4 times 6, what are you getting? 4 times 6, what are you getting? I'm getting 24, right? And then minus 4 times 2 is minus 8n. So please guys, when you multiply, please don't use your brain. Simply use the calculator. That's your advantage. Reason being, you can make a slight error or a slight mistake. So what we're going to do is we're just going to, whatever that's inside the square root, we're going to take it out. What do I mean by that? If you have the root of x, to take it out of the square root, we're going to say this is to the power of 1, by the way. It's going to be x to the power of 1 over 2, because there's 2 here that we can't see. If you have the root of x, the cube root of x, right, we're just going to say x to the power of 1 over 3, like that, right? So we're going to do the same with these problems inside the square root. Let's start off with the one at the top. So we're going to say 2 to the power of 4n minus 8, because it's a square root, which means we divide by 2, right? Multiplied by 2 to the power of 15, multiplied by 2 to the power of minus 6n, divide by, and then we're going to do this one at the bottom. It's 2 to the power of 24 minus 8n, and then we divide by the 2, like this, because it's a square root. And then from here we can simplify our problem. Here 4 divided by 2, 4n divided by 2, and then 8 divided by 2, we're going to get 2 to the power of 2n minus 4, right? Multiplied by 2 to the power of 15, multiplied by 2 to the power of minus 6n, right? Divide by 2 to the power of, so it's 24 divided by 2, it's going to give you 12, right? If you can see, we're having 2 to the power of 24 minus 8n over 2, right? Meaning it's 2 to the power of 24 over 2 minus 8n over 2, right? Hence I'm saying it's 2 to the power of 12, because 24 divided by 2 is 12, and minus 4n, right? So it's going to be minus 4n here. Fine. And then from here, we're just going to expand. We will expand this, we'll expand this. So it's going to be 2 to the power of 2n multiplied by 2 to the power of minus 4 multiplied by 2 to the power of 15 multiplied by 2 to the power of minus 6n. Divide by 2 to the power of 12 multiplied by 2 to the power of minus 4n, right? And then from here, collect the like terms, bases that have the same exponent. We're going to collect this one here with this one here, right? And then these are definitely like terms, so we're just going to add them. So we're having 2 to the power of minus 4 multiplied by 2 to the power of 15, right? And if you add these, so it's going to be 2 to the power of minus 4 plus 15. You're going to get 2 to the power of 11, right? So now we know the answer for this one. And then for these ones, 2 to the power of 2n and 2 to the power of minus 6n. So it's going to be 2 to the power of 2n multiplied by 2 to the power of minus 6n, of which is 2 to the power of 2n minus 6n, right? So it's going to be 2 to the power of minus 4n, right? So we're just going to write that down. So it's going to be 2 to the power of minus 4n multiplied by 2 to the power of 11, which is what we found here. And then divide by 2 to the power of 12 multiplied by 2 to the power of minus 4n, right? And you can see that this is 2 to the power of minus 4n, 2 to the power of minus 4n. They divide out. You remain with 2 to the power of 11 over 2 to the power of 12, right? You can take any up or down, right? I prefer taking this one downwards. Why? Because if I take 12, the 2 to the power of 12 upwards, I'm still going to have a negative exponent, which I'll have to return downwards. What do I mean by that? I'm having 2 to the power of 11 over 2 to the power of 12. I take this one upwards. I have 2 to the power of 11 multiplied by 2 to the power of minus 12, of which when you add the exponents to 2 to the power of 11 minus 12, it's going to be 2 to the power of minus 1. I still need to take it down so that I have 1 over 2, right? So what I need to do here is, so you can simply say this is your answer, right? But as I said, I'm just going to take the 2 to the power of 11 downwards. So I'm going to have 1. There's 1 here that you can't see. So it's multiplied by 1. Divide by 2 to the power of 12 multiplied by 2 to the power of 11, right? But it's negative because it was positive at the top. So same base, add exponents, you're going to have 1 over 2 to the power of 1. So that's the answer. The answer is 1 over 2, right? So the answer is actually 1 over 2. That's your final answer for this problem here. So as I said in the previous problem, always do your checks. Your checks, you are checking on whether or not your answer is correct. So in this case, we found the answer to be 1 over 2, right? So you're going to do your checks. How would you do your checks? You're going to write down, or you can just go back to your original problem of 4 to the power of 2n minus 4 multiplied by 8 to the power of 5 minus 2n, divide by the root of 16 to the power of 6 minus 2n, right? Substitute. So you're going to substitute any value of x. So x equals to 1 or x2 or 3 or 4. It's up to you. Substitute any value of, obviously this is not x, right? It's n. So please substitute any value of n. So it's going to be n is equals to 1, 2, 3, 4, any value. But substitute constantly. If you substitute here, you substitute n equals to 1. Obviously here is going to be n equals to 1, and then here n equals to 1, right? Or 2 or 3 or 4, any value, even if it's negative 1, negative 2, negative, just substitute any value of x and punch it in your calculator. So you're just going to substitute it here and punch everything in your calculator. If you get this 1 over 2, then that means that our answer from the previous solution is correct, right? So that's how you check yourself if you've simplified these problems correctly. Cool. So now we're done solving these problems here. I'm just gonna give you problems to do, which is this one here. Please try out these problems and let me know in the comment section if you are getting the answers. It's really important so that I know that you are doing well or you are struggling somewhere. So please guys, take this seriously. So the first problem that I would like you guys to do is this one. So it's 5 to the power of x multiplied by 9 to the power of x plus 1 divided by 3 to the power of x plus 2 multiplied by 15 to the power of x minus 1. Right, please try this out, and also try this out. The root of 8 to the power of x minus 2 multiplied by the cube root of 9 to the power of x divided by the cube root of 6 to the power of 2n minus 9 multiplied by 2 to the power of minus x over 6. Please try out these two problems. Let me know what are you getting. And
thank you so much for watching. If you have any questions, suggestions, or comments, please write them down in the comment section below. Otherwise, please subscribe to the channel and don't forget to click that bell button.